Hi ladies, so this is our last hybridization, which are for triple bonds. These bonds are called sp hybrid orbitals, and we're going to do this with C2H2. So it's, as you can tell, it's not very different from the previous example, except now we have to figure out what's happening to these electrons. So let's go ahead and put our 6 electrons into our electron configuration. So it's 1, 2, 3, 4. 5 is an up and 6 is an up. And this is for our carbon right here. We have a second carbon right here, and so let's go ahead and fill that with its 6. So here's 1, 2, 3, 4, 5, and 6, which is our up. And if you notice, this now has only 2 H's. So I'll draw 1 H up here and 1 H up here. Just to label them, I'll label them in blue. Here's our H, and here is our H. And each of these is going to have one up electron, so here's an up, and here's an up. Alright, so if you take a look, let's go ahead and see how we can bond these. So I could create a bond here, and I could create a bond here. The nice thing is I can also create a bond here. But if you notice, not all of my orbitals are filled, and we need to hit the octet rule. So there has to be a way to get electrons in this box as well as electrons in this box. So let's take a look at what kind of hybrids we can create here. So I'm going to undo all of these. And from our previous examples, what kind of hybrids do we usually create? Well, if this is called an sp hybrid orbital, we should once again create hybrids with our s's. So I'm going to move up this s orbital up here, and I'm going to move up this s orbital up here. And now that they're in the same level playing field, I can have this electron share into this area. And once again, I'm going to do my parallel spins. And over here, I'm going to do the same thing. I'm going to move it over, make sure I have my parallel spins. And now I've created four different orbitals in each carbon that allows for bonding. So what we see is this hydrogen is going to bond to this. Let me draw that a little bit better. But this hydrogen right here is going to bond to this orbital. And that way this electron is going to move back and forth and share and provide a pathway for this electron to also share into this H. This electron right here is also going to share and move back and forth on this path. And now we have to take a look and see how can we get this carbon to link up with this carbon. And if we count these correctly, I have one bond that can occur between these two. I have a second bond that can occur between these two. And finally, I have a third bond that can occur between these two. So if I have 3 bonds between the two C, or the 2 carbon atoms, what kind of bond is that? 1, 2, 3, which is a triple bond, whereas each hydrogen is bonded only one time to the carbon. So let's do the structural formula for this. And so I had the 2 C's with 3 bonds between them, along with the 1 H on this carbon and the 1 H on this carbon. So let's go ahead and take a look at how this picture is drawn. Once again, you can take a look at your book in chapter 8.3 if you would like to see their models. So what we see is we are going to create this carbon right here and this carbon right here. Okay. What we've done is we've created that hybrid of an sp right here, and the other two that remained, and let's do the py up here, and let's also do our pz. Let's do it in purple. Here's our pz. So now let's go ahead and take a look at what kind of bonds we create. So the first thing we notice is there is an H on each side. So here's one H, here's another H. And let's go ahead and label these as H. Let's take a look at whether or not they create sigma or pi bonds. So here we have a bond on the axes and a bond on this axis. And so like we said before, that's going to create our sigma bond. So here's a sigma bond, here is a sigma bond. What we also see is in the middle, I've created a bond between this orbital and this orbital. If you notice again, it's also on the same axes. So this is also going to be labeled as a sigma bond. Now let's take a look at our PY and our PZ. So if I get these Y's to get closer and closer together, it's going to create this two horizontal sausage bonds, which like the previous example occurred, right? And so once we said the bond is either here, or sometimes the electrons may move that bond up here, but instead, since these bonds are not on the same axes, they create these two different orbitals. We know these are not pi orbitals, but these are not sigma orbitals, but the ones are pi orbitals. So let me go ahead and write that in. So here's my pi orbital. Now the tricky thing is we need to find out what's happening with these purple sections. So if this gets really close to this, you're going to notice that it does the same thing. I have another set of sausage orbitals right here. And once again, these are not on the same axes, so this is going to be labeled as another pi bond. So whenever you have a triple bond, you're going to see that, yes, I have these sigma bonds, but I am going to create two sets of pi bonds. Once again, like I said, this section is visually challenging, but it does take practice, so be patient, try it out, practice these drawings on your own, and make sure you really understand what's happening in the hybrid process, which is here, but being able to visualize and draw what's happening in reality. So what you have for homework today is, don't worry about this section, we're going to work on that in class on Monday, but for homework I would like you to do this and to just practice so we can start reviewing for our final. Good luck, and come see me for tutoring or in class if you have any questions on any particular pieces. Thank you.